Okay, so today we're going to cover how we can find and use slopes of lines and how we're going to tie it to geometry. So let's go ahead and first define what slope is. So slope of a non-vertical line is the change. So again, slope of a non-vertical line is the ratio of the change in y to the change in x. So the change in y will be a vertical change. The change in x is going to be a horizontal change. And slope is usually indicated by a lowercase italicized letter m. The formula for slope is y2 minus y1 over x2 minus x1. You probably also learned that slope is rise over run. And that's what's written in red and blue over there in the graph. So rise over run. Okay, so we'll be learning how to find the slope of a line. Either you're going to be given 2 points, and you're going to plug those 2 points into the formula. You'll be able to figure out the slope from a graph. You could count the rise and the run. Or you might also be given an equation. So we'll be learning to find the slope from these 3 methods. Yes?
Is there going to be a test on this for this quarter?
Yes, there's a no. Wait, let me think. All right, so yes, there is a test. It will cover all of chapter 3, and it's on October 15th. All right. There are 4 types of slope. We will have a positive slope, and that's when your line rises as it moves to the right. A negative slope falls as you move to the right. A zero slope would be a horizontal line, and an undefined slope is a vertical line. Now, you need to memorize the bottom 2. The positive slope, it's easy. You can see it, the line as you read it and go across the page, it's going up when you move from left to right, and then the negative is falling down. However, the zeros, sometimes these 2 slopes down here at the bottom, students get them confused. So, for example, the equation for this line here, it looks like it's hitting it at about 1 on the y-axis. So the equation for this line that's graphed is y equals 1. So if I ever gave you an equation and I said find the slope of that line, whenever it's y equals a number, the slope is 0. But whenever it's x equals a number, it's going to be an undefined slope. And let me change that. I think that looks like it's hitting at about 2. Now, little tricks maybe to help you remember. You could look and see horizontal has 2 O's in it. So you might think those O's look like zeros. That would be the 0 slope. The word undefined, if you know that it's a vertical line, you could say that a vertical line is up for the U, and then the N is and the D is down. So when the graph of your line is up and down, the slope is undefined. When we find the slope from 2-order pairs and we get our answer, if you recall that when there is a 0 in the top of the fraction, and then it doesn't matter what's in the bottom, it could be any number, this simplifies to 0. But when the 0 is in the bottom, that's the undefined slope. So when I'm asking you to calculate the slope from 2-order pairs, you need to simplify those fractions. If you leave it like 0 over 4 and don't tell me that that equals 0, you're going to lose points. Over here, let's say you got as your answer 5 over 0, and you didn't tell me that that simplifies the undefined, you're going to lose points. So you need to memorize that when the slope is a horizontal line, or when you have a horizontal line, the slope is 0. When the line is vertical and it's up and down, then it's undefined. So be able to find the slope of a line from a picture, from a graph, so from a picture which is a graph, or finding it from an equation, which could be y equals 1, x equals 2, or also find the slope given 2-order pairs. The next thing we're going to talk about is the steepness of a line. So the greater the absolute value of the line slope, the steeper the line. So for example, let's say I calculated y2 minus y1, x2 minus x1, and the first time I did the problem, I got a slope of 5. The second time I did this same problem, whatever the ordered pairs were, and let's say I got a slope of 2, the steeper line would be 5. Now, let's say I got negative 6 as my answer, then this would be the steeper line, because notice it says absolute value. So you ignore the sign, and this would just be a line that's going down, but it would be steeper than either of these two, because the absolute value of negative 6 is positive 6, and 6 is bigger than 2 or 5. So the bigger the number, the steeper the line. Now we're going to see two postulates that we're going to tie them to geometry. And you probably learned this in Algebra 1. So in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So if you remember from Algebra 1, when you have two equations that had the same slope, then you could say that those lines were parallel. So when they have the same slope, they're parallel. And they've drawn two parallel lines here. Notice they have these little arrows or these little triangles on here, indicating that the red and the blue line are parallel lines. Okay, also keep in mind that any two vertical lines are also parallel. So remember, parallel have same slope. Perpendicular, they're going to have opposite signs and reciprocals. So opposite reciprocals form perpendicular lines. So here it says, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. One other important thing to note is that a horizontal line with a vertical line also form perpendicular lines. So for example, if I draw a horizontal line here, and then I draw a vertical line, notice where they meet and cross, they form perpendicular lines. So what I mean by opposite reciprocals, let's say the first slope I calculated gave me a slope of 2/3. An opposite sign and a reciprocal to 2/3 would be -3/2. So when you have two slopes and they're opposite signs and then they're flipped reciprocals of each other, those form perpendicular lines. Now let's say it's a whole number. Let's say it's 2, or let's say it's an integer. And then the opposite reciprocal to 2 would be -1/2. So these are opposite reciprocals. Now, this one right here, the last bullet point, horizontal line, remember, has a slope of 0, and the vertical line has a slope that's undefined. So undefined and 0, because if you think about it, it's 0 over a number and a number over 0. These are opposite, they're not opposite signs, but they're reciprocals in a sense, because the zeros switch. But a vertical and a horizontal line also form perpendicular lines. And again, the little box, when the two lines intersect, indicates that it's a right angle, and then that would be forming perpendicular lines. Now, I notice in the definition it says that their products are -1. So let's watch when I multiply 2/3 and -3/2. I could just multiply without simplifying and get -6/6, and it gives me -1. If you like to simplify on the diagonals, you could change all these to 1s, and then you're just left with -1, either way. So when you multiply something by its opposite reciprocal, your product will be -1. So, first example, The slope of a vertical line is blank 0. Sometimes, always, or never. Never. Good. Vertical line, remember, is up and down. It's undefined. It's not 0. Okay. Slope of a horizontal line is blank 0. Beautiful. Slope of a line that rises to the right is blank positive. Nice. And the slope of a line that falls to the right is always negative. Nice. So we just applied everything we just learned into sometimes, always, and never questions. Now we're going to practice the slope formula. So again, remember the slope formula is y2 minus y1 over x2 minus x1. And that gives me the slope. And again, remember slope is indicated by a lowercase letter m. Now, when I go to use this slope formula, it doesn't matter how I label my ordered pairs. So I'm going to label in example A here, this first ordered pair is going to be my ordered pair number 1. So I'm going to give each one of those an x1, y1. Okay, those little ones are like labels. They're subscripts. So this is ordered pair number 1. And now I can say this one is ordered pair number 2. It doesn't matter if I would have labeled the first one as x2, y2. I still get the same answer. So let's go ahead and plug them into the formula. So 5 minus 4 divided by negative 4 minus negative 3. Be very careful when your ordered pairs have negatives in there. So notice on this one that negative in the bottom is going to turn into a plus sign. So then this becomes 1 over negative 1, which simplifies to negative 1. Let's try the next one. Again, label it x1, y1, x2, y2. Subtract. Negative 2 minus negative 3, negative 1 minus 6. Do your keep flip change here. This turns into a plus sign, and you get 1 over negative 7. Now, just to demonstrate that it doesn't matter, I get the same answer. Let's say I took these same ordered pairs, 6, negative 3, and negative 1, negative 2. And let's say this time, I'm going to say this is x2, y2. This is x1, y1. I just want to show you that you still get the same answer. So if I do negative 3 minus negative 2 and 6 minus negative 1, notice again, keep flip change, this turns into a plus, negative 1 over 7. Remember that when there's one negative sign, it doesn't matter where it is, like up here, the green one, I could say this is really negative 1/7. Same thing on the blue. Okay, so as long as one number has the negative sign, it still means the same thing. So it didn't matter which one I gave the label as the ordered pair number 2 and which one as ordered pair number 1. I still get the same answer. Okay, let's try the next one. Again, let's label it x1, y1, x2, y2, negative 4 minus negative 4 over negative 3 minus 8. Do your little keep flip change here. My numerator becomes 0 over negative 11. You need to realize that when there is a 0 in the numerator, this will simplify to 0. And we'll do the last one. I'll do the work down here. But again, x1, y1, x2, y2. So here, 9 minus -2, -6 minus -6. Do your keep, flip, change. Big plus sign, big plus sign. This gives me 11 over 0, which simplifies to undefined. Make sure you simplify those that have the zeros and either turn it into a 0 or an undefined. Know the difference. Now, biggest mistake that I've seen in the past is when students work with the slope formula, they forget that y goes on top. I always like little stories or tricks to help students remember. So last year when I was teaching this, actually to my Algebra 2 honors class, so again, you're going to learn it again next year. It doesn't go away. He told me that back when he learned this back in elementary or middle school, that his teacher told him that you're going on a picnic and you're going to have your picnic on the side of a mountain which has a slope, and you're going to build your picnic table. So the picnic table is going to be built with the X's. Those are going to be the legs of the picnic table. Then on top of that picnic table, you're going to put your glasses and you're going to be serving yum yum juice. So that's going to be your Y's. And then he gave me some more things about, something about putting olives in it and stuff. But just remember that the X's go on the bottom. That's what builds your table. And then you put your glasses for your yum yum juice at the top. So whatever's going to help you remember that it's y minus y on top, x minus x on the bottom. Make sense? So whatever little tricks help. Pretty good? All right, so it says to complete the table for r parallel to s and r perpendicular to t. Now, what did we learn just a couple slides ago about parallel lines? What do they have in common? The slope, right? They have the same slope. So what we're going to fill in under the R column is going to be the same thing that's in the S column, because R and S have to have the same slope in order to be parallel. Now, for the perpendicular part, we're going to be filling in the R in relation to the T, and we know that perpendicular lines have opposite signs and reciprocals. So if I go across this first row, notice R and S need to have the same slope. So under the S column, I'm going to put -1/2. Then under the T column, I need it to be perpendicular to this slope. So I'm going to make it opposite sign. So it'll be positive. And then I flip that 1/2 upside down and it becomes 2. Everybody with me? All right. Now we're working backwards. They've given me the T slope, and I need to find the opposite reciprocal to that T slope. So opposite sign, I know my answer is going to be negative, and then I flip that fraction upside down. So this would be -6. Next one, they've already given me the slope for S, so I know the slope for R is going to be the same. And the slope for T is going to be opposite sign and flipped upside down. Now, the next two look kind of scary, they're variables, but we're still doing the same thing. So if I wanted to think of A as A over 1, to get its opposite reciprocal, I just flip it to 1 over A and make it opposite sign. And then same thing for the 3b over 4. Flip it upside down and make it opposite sign. And you're done.
You skipped D.
Oh, thank you. All right, so I skipped D. So D, the R and the S are the same, and then flipped upside down is 1/4. Thank you. All right, next example. If R is parallel to S and R is a horizontal line, what is the slope of S? What's the slope of a horizontal line?
0.
0. Okay, so horizontal line, the slope equals 0. So because these lines are parallel, they have the same slope. So the slope, and again, you could write it as m equals, is 0. And one more example. If k is perpendicular to n, and n has a slope of 0, what is the slope of k? Undefined. Because remember, on that slide back where we saw about the perpendicular lines, a vertical and a horizontal line together form perpendicular lines. So the horizontal has the slope 0 and the vertical has the undefined. So k would have an undefined slope. This is the question when I would teach this to my Algebra 1 that would trip up a lot of people. They would remember that perpendicular have opposite reciprocal signs, so like 2/3 and negative 3/2, but they would forget about the 0 slope and the undefined slope. These also form perpendicular lines. Okay, so tonight while you're doing your homework, some of the questions ask you to graph ordered pairs. So you need to find a picture of a graph, maybe put it into your Notability, or draw the graph yourself. So on the questions that say graph, you do have to graph them. Okay, so it's easy to find a picture of a graph and then just put that picture into your Notability so you can graph your ordered pairs. So some of the questions require graphing. So you do have homework. It is due on Monday. And then when we return Monday, we're going to finish up. Okay, so we will cover 3-5 on Monday, 3-6 I think on Wednesday, and then we'll start reviewing for your test. And then your test will be the following Tuesday. So not next week, but the week after. And that'll be your last grade for the quarter, the last major grade. Okay, so you still have some homework grades, but you do have one more test. No more quizzes.